Okay, good morning, everybody. Welcome to day 2 of our Virtual Technology Week. This session is entitled Tank Floor Scanning Systems. It is our session 8 out of 33. I see we've got a whole bunch of participants on the line. Some of you I recognize, so welcome to everyone. My name is Quentin Bauer. I'm the General Manager at Intech NDE, and I'll be the moderator for the session. The way we're going to run this is that we'll keep going until 5 minutes before the hour, and then we'll terminate the webinar. Please feel free at any point in time to ask questions with the Q&A button. We'll do our best to answer the questions real time or perhaps after the presentation. Again, we're very grateful to our suppliers for their participation in the Virtual Technology Week. We really appreciate it. Without them, this wouldn't be possible, and we wouldn't be able to put all these sessions together. I'd like to introduce our first speaker for the session. We have Pete Burrows from Bowen Whedon. Presently, Pete is the Director of Sales at Bowen Whedon. Previously, he has worked as an application manager at GE Inspection Technologies. He's also worked at Staveley NDT and has a lot of field experience through Oceaneering and Doughty Aerospace. So without further ado, I'm going to hand over to Pete. Welcome, Pete.
Hello, everybody. So good evening or good morning for most of you guys.
It's good morning, yeah. I think it's a chilly morning.
Is it? Okay. We've had snow, but not snow like you guys get.
It's more the temperature that's the problem.
Absolutely. Okay, shall I press on? I'll start sharing.
Yes, please. Thank you. Yes, perfect. I can see it. Thank you.
Yeah. Hello, everybody. As Quinn said, my name is Pete Burrows. I'm the Sales Director for Bowen Whedon here in the UK in Hereford. So not many miles from the Welsh border, if you know the territory at all. I'll quickly run through the our tank floor storage. Just check this out. So we manufacture a thing called the Truflux, which is an oil storage tank floor scanner. And I'll just give you a little bit of background of the company, how we came about building the scanner, how the scanner works, and I've got a few videos and some talking through the software. So hopefully you'll find it interesting. Trying to make it as light and not too high tech or too techy as possible. And feel free to post any questions as we go along. We have some poll questions as we go through, which my colleague Gath, who is online, Gath is the sales manager for Bowen Whedon and our sister company Ether. So Gath, I think, is going to poll the questions as we go through for us. So this is us. We are a relatively small company, sort of circa 20, 25 people. Based, as I said, in Hereford in the UK, not far from the Welsh border. The company has been going since 1968. It was originally founded by a couple of guys, Trevor Bohr and Peter Whedon, both who have passed away, unfortunately, certainly Trevor Bohr in the last few years. And we actually have Trevor Bohr's son who still works for the company, so there is his family link still here. It was founded as an ultrasonic company, basically, in those days, and things have moved on over the years. The Bohr family sold out. And there's a whole lot of history there if we could go into, but we don't need to right now. So some of you may know a guy called Mike Riley, who was CEO of Sonotest for quite a few years. When he left Sonotest, he found our sister company called Ether NDE with a guy called John Hanson. So Mike's been in this business for an awfully long time, as long as Gath and myself, so sort of 30 odd years, I guess. And I said John Hanson and Mike founded Ether 10, 11 years ago now, and Mike then bought Bowen Whedon from another group in 2012. In those days when Mike took this over, we were primarily manufacturing magnetic particle MPI benches and a few accessories, along with thickness gauges, which are a hangover from the original days. What's happened in more recent years since Mike's had the businesses, we've grown into many more different markets and many more different products. Hence the reason you're probably hearing from us and maybe not heard from us much in the past. We are certainly growing at a decent pace, which is good. And we have lots of new products. Some products we make ourselves, some we buy in. So we work with other companies to develop. So hopefully you're on here because you have an interest in tank floor inspections. Magnetic flux leakage is the technique that we're talking about here. So I'll just use my cursor so you can see this. This is what we're talking about, inspecting these sort of things. So these are oil storage tanks. They do what they say on the tin. They store oil or petrochemicals for onward processing or shipping, or just keeping them while they're waiting for the price to go up. So it's quite an intense market. There's a lot of these things out there, and there's a lot of times when they're all very full or getting empty quite quickly because people need the fuel out of them or the oil out of them. And the bit we're interested in is the actual tank floor bottom, which is essentially, as you can see on this picture here, it's a huge flat steel disc made up of rectangular plates. So we have these plates inside, so basically steel plates welded around the perimeter to each other to make up the tank floor. You have a tank wall which is around the outside, and you have annular plates which the tank wall sort of sits on, or it'll give it some extra structure around the outside. We're interested in finding corrosion in the tank floor itself, whether it be top side or bottom side corrosion. Obviously, there are some quite hefty penalties for leakage of hydrocarbons into the soil in almost all countries in the world these days, I think. Certainly in the UK, the health and safety people and the environmentalists are quite rightly, it's a huge fine. It's corporation-wise, it's not a very good thing to be doing. Certainly not something you want to be having splash shows in the newspapers. So everybody is interested in stopping or finding problems before they actually cause leaks. And I think magnetic MFL is actually one of the easiest techniques to understand. It's essentially, as you see in the picture here, we've got a north and south, sort of like a horseshoe magnet. In this case, it's actually quite long, so when the axis is going away from us, it's in our case about 300 millimeters long. These are very, very strong magnets. And this is the tank floor here. So the tank floor plate is really saturated with magnetic flux. And as long as everything's in equilibrium, the flux stays within the floor plate. If you get something like this, a corrosion pit or some sort of anomaly that reduces the wall thickness, in simple terms, there's not enough volume of material in that area for the lines of flux to stay within the material, within the steel, so they get pushed out of the surface. Top and bottom, the flux lines are disturbed. And what we're interested in with the tank floor scanners is picking up with a sensor of some description that disturbance, how the magnetic flux lines are being altered as you scan across the tanks with these scanners. In our case, we use Hall effect sensors. I think there are some older machines that used coils to pick up the flux straight or the flux leakages. We use Hall effect sensors. And very simply, we have 48 Hall effect sensors across the sort of 300 millimeters of the scanner. We register what each one of those sensors is doing as we scan along the plate. So we're getting a sort of 300 or 275 mil wide scan at whatever speed we move the scanner forward at, typically 500 millimeters a second. And we're looking for this type of thing. This document came from a recommended practice. Is a UK Health and Safety Executive document here. So I've cribbed a little bit out of this. It's actually a very good document to get transferred. It's 2006, so it's reasonably old, but it is very current and gives you a lot of background into magnetic flux leakage. So, and these are typical things. So a general loss or corrosion, area of corrosion on the back side or the top side. You can get clusters of pits, top side or bottom side. But one of the hardest things with any of these techniques is trying to find an individual corrosion pit. We're looking for generally slightly larger areas, or certainly a corrosion pit that has some more size to it, not just a very small sort of microbial induced pits. You're not really going to find those very well with tank floor scanners. And in fact, the document, the Health and Safety Executive document I referred to, does say that what they did, they discovered that, yeah, corrosion pits are the hardest thing to find, and you're probably going to struggle to find them. But that's kind of holy grail for all of us in NET, trying to find the smallest defects in the largest area in the quickest time, which actually MFL is quite good at. Sort of flux leakage and Truflux scanners are quite good at that sort of thing. Just click on here. Oops, sorry. So the scanner, where did it come from? It's basically it was designed for Germanischer Lloyd in Singapore in the mid 2000s. Let's get rid of this thing down here. It was a British engineer a guy called Chris Wing, who developed. He was employed or on contract with GL at that time. They were in the market, I believe, to buy 10 tank floor scanners. They looked around and said, actually, what we're going to pay for these things, could we develop our own? They employed Chris to basically do that job. And the Truflux is a result of his work. So they built their own unit, they used them for quite a few years. And actually all of those units, or certainly most of those units they built in those days, are still out in Asia, in parts of Asia being used at the moment. And we do see, we know some of the guys who are using them, we see some of them, we certainly talk to them about spare parts and bits and pieces, but the reality is most of those guys now keep them running for themselves, which is one of our big selling points we'll come on to shortly. That is, the rights to the scanner stayed with Chris. I don't know how that worked. He had quite a good deal. And when he was back to the UK, no longer working for GL, and GL actually pulled out of this business, the tank floor scanning business completely. So they had no long interest, and that's why they sold the scanners off when they finished that interest. Chris retained the rights, and we've worked with him ever since sort of 2014-15 approximately to build the units, initially under his guidance, but since then we developed them onwards ourselves. And also you'll see a little bit of the development here as we go through. These are some of the things we've done recently. This picture here actually is a slightly old picture. The battery mechanism, the battery design has changed now. We've actually gone something a little bit more easy to ship, as you'll see in the text here. So we've improved the encoder mechanism. We found we never really had a lot of encoder problems, but it's quite hard to, with the small encoders we use, to get replacement encoders in a good time. So we've gone with a more basic encoder, fitted it in a different place. And it's something you guys or customers can certainly buy themselves and fit themselves just by simply putting a LEMO connector onto the encoder cables and off you go. So we've improved the encoder mechanism. We've moved the encoder within the machine so it's less likely to get any damage anyway. And we've also designed it to be more customer serviceable. We've changed the motor controller. There's a board inside the machine which controls the speed that the motor drives the scanner forward at. We have a new laptop dock in recent years. So you can see one behind me. If you can see my picture, there's one behind me. So we use a GTAC laptop at the moment, but essentially any Windows 10 or Windows-based laptop will do this job. It's not particularly difficult software. We've added some perimeter scanning wheels to the side of the Truflux. So if you want to do the annular plates with the scanner, you can. You simply just drive it and it will follow its way around the outside of the tanks. Excuse me. We've changed, as I mentioned briefly just now, we've changed the batteries from a single lithium-ion battery to a couple of actually lead-acid batteries. It sounds like a step backwards, but we were finding, if you can see on the picture here, oops, this battery here was actually from an electric bicycle, and they were good batteries. They power the thing for quite a long time, but we found there were quite a lot of copies that didn't fit quite as nicely on the machine, so it gives a lot more problems. But our biggest issue is shipping these batteries around the world because they're above the 100 watt-hour capacity. Shipping them is quite difficult. And actually, we don't need a battery like that. We've discovered that a pair of lead-acid batteries, which you can buy anywhere in the world, and essentially any 24-volt supply will power this thing. We chose lead-acid, but in the future we could add other battery options. And if you got stuck in the field, there's no reason why you couldn't just go and find a 24-volt supply and run it yourselves. And one of the important things we've done recently is added an alarm on defect software. We've always had mapping software in the machine, which gives you generates a full map of the inside of the tank and documents the results, and you can interrogate each plate at a time and have a look at the whole tank and things like that. We didn't, until last year, we hadn't done sorry, previously we haven't actually done any alarm on defect. We don't do stop on defect. This is the motorized scanner, but it doesn't have stop on defect. So we came up with a system called alarm on defect, which essentially it doesn't store data. It stores a little bit of data, as you'll see as we go through, but it doesn't really store much data. It's very easy to use, and you just simply drive the scanner along in one direction, and it gives you results of that track you've just scanned. Quite easy to use and actually easy to train people on. These are things that were in the machine originally. It's kind of one of the benefits it's always had. It's a high resolution mapping system. So as you scan forward, we take in the direction of scan, we take gather data every sort of 3-5 millimeters. That's adjustable. Typically running at 500 millimeters a minute forward. We can go faster. We've not really done the work, and I'm not sure there's that much we need to drive scanners at a meter a second. We can do it, but generally 500 millimeters a second seems to be okay. And as across the width of the scanner, we are gathering, or we're taking a reading, or a measurement, or sensing something about every 5.5-6 millimeters across the width of the scanner. Sort of every couple of mil, 3 mil, 5 millimeters as we go forwards with the scanner. That's typically how we set it up. One of our key features really is that the machine can be split into small parts. The head is detachable from the handle. The handle comes into 2 pieces. The laptop is detachable, as are the batteries. So it can be packed out into small cases. The whole thing is under 60 kilos, and actually we can get it into 2 boxes of about 25 kilos each, which I think is quite good for this type of thing. So you can ship them all around much more easily, and actually carry them around much more easily than a fully sort of non-collapsible scanner. We have this unique pivot system, which you'll see in the video, for breaking the scanner off of the surface of the plates. And as a bonus part of that, we have dampers. When you put the scanner back down onto the plate, it doesn't slam down onto the plate with a bang, like a lot of tank floor scanners do. Bearing in mind that the magnets that we use, proportionally, some people say, I've not tested it, but we're told they can lift about 500 kilos, the magnets. So when you try and put them in contact with the plate, they do go down with a bang. If you don't have this sort of system that we've got, which allows the scanner to lower gently. You'll see all that in the video shortly, which actually I need to press on with, otherwise we'll be here for a long time. This is the inside of the scanner. I'll go through that in the video. There are things you can do yourself. One of our big selling points really is the fact that you can do a lot of maintenance and repairs on this scanner yourself. We pride ourselves really in giving you the information, giving you the help to do these things in the field if you get problems. Luckily, we don't get that many problems, but we are willing to help people repair them themselves, or certainly guys like Intech locally. If you don't want to do it yourselves, the local guys will help and repair these things. It's not a difficult device to repair. So this is the what we call the alarm on defect software. It's what it says. Basically, you scan along, and if you see it, the machine sees a defect, it gives you an alarm. You can set a threshold for that alarm. It captures quite a lot of data, or it captures a bit of data, but there's a lot more to it. It's gone on in the background that you're not really aware of when you're scanning, but it is actually a very nice way of scanning and seeing the results very, very quickly and very easily, and actually immediately. Whereas the mapping software, and most mapping software, is a bit of a delay. You have to finish a track and then view the data. With the alarm on defect, you're viewing the data there and then. I won't go stay on these slides too long, because this is all covered in the video shortly, which I will talk over at the same time. So this is the calibration screen for the alarm on defect. And this is the actual live scanning screen that you see. So in the middle here, you have the scan as you see it in the small area magnified, and down the right-hand side here is kind of a videotape. That's what the side, the symbols mean, or the perforation. It's essentially like a videotape of the scan that you've just been doing, the tracker data you've just been doing. If you go over a defect, this idle light, when you're moving, it goes green, and I think it says go or okay or something like that. It turns red and says alarm when you go over a defect. And every defect you find pops up in here to list the defects you've seen, and they're also recorded on this tracker data here. And there is a little bit of plate storage information kept here if you want to. Again, that's not something I think we actually need to do. I think it's more than is required of this software. We'll go through that in the video. This is the, again, we don't, with the alarm, you don't really pull out a report as such, but it does give you a screenshot or a very, very mini kind of report of a defect. So if you wanted to say, I was scanning a track, and you want to give something to somebody to say, look, there was a defect there, this is the kind of thing they'll get. It tells you the location along the track. So in this case, it was 1132 millimeters along the track, and the defect sizes it saw were positive 97 and minus 90, minus 82. So it's showing you the positive and negative. You always get a sort of a north and south effect on these defects. So that's what it saw. This is an overview of the mapping software. What we do with the software, we get a tank floor map here. So you put in diameter of the tank, in this case 25.4 meters, and you start to build your plates up within that tank. And each one of these plates is one of those steel plates we showed on the previous pictures. The general way and I think most people number them, you have a top row of plates here, so it's 1.1, 1.2, 1.3, so on. You build up 2.1, 2.2, and so on until you fill that kind of hole the inside of the tank with plates. And on the annular plates, we list here the numerical sort of list of annular plates 1 to 14. So they're not stored, they're not actually pictured on the outside of the perimeter or the perimeter of the tank. They are just a list of plates. So we're not pretending we are the world's finest software, or we don't have the world's finest mapping software for these machines, but we do have a very easy to use functional software that is essentially comes for free. Both these softwares, by the way, come with the machine for free. They're included, and we don't have any issues on license. If you want to have another copy of it to replay the data on another screen, that's fine. We allow you to do that. There's no charge for that. Let's just go through. Within this software, you have these sort of 3 screens here, which I'll talk about more in the video. Okay, so I've got videos here. I'm going to run video 1. I will talk over it as it goes. Hopefully this works. Okay, I will actually, because we're going to run out of time if we're not careful, I will skip the little bits of this as we go through. So you'll see this is the same room I'm in at the moment, and this is actually the same scanner that I videoed the other week. This picture of the scanner itself, we're just going through, so I'll pause as I go through if needs be. So this is the GTAC laptop as we discussed. And just here, this is the actual button you press to drive the scanner forward. We used to have a trigger, but actually this button works just as well. So you press the button, scanner drives forward, and you start gathering the data. So I keep going. That's the laptop. Again, any Windows laptop will do the job. So this powers the batteries on. This box here is essentially the lead acid battery box. It's a very simple thing. You take the cover off here, take the lead acid batteries out, recharge them, put them back in, or have another set charging in your workshop and outside the tank and put them back in. Very, very simple. Any 24-volt supply already. And the power connectors now, we've got these military style connectors to make the connections to and from the battery box a little bit more robust. And the laptop dock. I should mention, this is a very well-used scanner. It's our demo scanner. It's our development scanner. It's the one we use for everything in-house here. So excuse the scratches and the marks on it. It actually came out of a tank not so long ago where it was essentially filled on the inside with debris because the customer hadn't, we were demoing, the customer hadn't swept the floor of the tank properly. So these are the connections. I think what's important with our scanner, you have the power connection, which is the battery power and the switch to turn the motor on and drive the motor forward. And you have a USB connection here. And that's the only connections you have. All of the data, everything you need to actually gather the MFL, the results come up through these USB cables. It really is a sort of plug and play device, very, very simple. Okay, I'll just pause here so we can get a better view of the side of it. So this is the side view of the scanner. This is the magnet bridge here that I showed you a brief picture of in one of the earlier slides of the theory. So we've got a north and south pole magnet here. It saturates the plate with magnetic flux, and inside this bar in the middle are all the sensors. These are set 3 millimeters off the surface. We've set those to be optimal for most plates between 6 and 12 millimeters. If you're doing all 6 millimeter plates, you'd probably put a little bit more gap on these. If you're doing all 12mm plates, we get them a little bit closer to the plate. It's the 3mm gap for the mags is optimal for most plates. But if you're doing a lot of one end of the scale, then we'd move them slightly. And the sensor bar we set about 1 millimeter off the plant floor. It's sprung loaded, so if it does hit anything, any debris, it just runs over it and doesn't cause it any damage. Okay, so this is the scanner. Okay. I'm just going to pause here. I will skip some of this. So this is the inside of the scanner. You've seen some previous pictures on the PowerPoint. As I said, bear with me a second. As I said previously, this is our demo scanner. It's also our development scanner. So we have, excuse the cables, but this is the motor and gearbox here in the middle. We have drive belts down to the front wheels, which are these are the devices that move it along in the tank. The encoder is now mounted up here out of the way. It runs off one of the slave non-driven wheels. So if that wheel is going round, but this encoder is driven off, it means the scanner is moving. So you don't get any false data. The encoder is reading live all the time. On this side, you can't see in here, is the motor driver board. So essentially, it's quite a basic device, mechanical thing, machine. I'll just skip forward as we're going to run out of video time here. So what I'm showing in the video now is the mechanism where it breaks the scanner off of the surface. So here we go, just lifting it off. It's quite easy. You can literally push the handle down with one hand and break it off the surface. And the important thing, as far as I'm concerned, is when you lower it back down, you can put it down softly. It's not banging down with 500 kilos of force instantly onto the surface. Okay, so this is me now driving it along a plate. When you're in the field, this is what you're doing. You're essentially, obviously the plates are much larger than this, you're essentially driving it up and down the plates, gathering data in either a unidirectional or a sort of raster pattern. Okay, and this is the laptop we've chosen. This is our fully rugged laptop. It can also be used as a tablet, as we're just showing it here. Okay, we're just going to move on to the software quickly. Okay, this is the alarm on defect software. The first thing you'd go through is to calibrate it when you turn on. Every time you use the machine, you need to calibrate them on a known plate. So we have a plate with a 40, 60, 80, 20, 40, 60, 80% defects in them. And then we get this kind of image to start with. Let me just pause this a second. So the first thing to do when you do a calibration is clean up the background. So it's kind of tidying up the background. So you click on a base background level here. We clean up the background, then we select the 20, 40, 60, and 80% cursors to the 20, 40, 60, 80% defects. So that's what the next part of this video is about. Okay, so it's just putting up a 20% here. I won't go through all of this because we're going to run out of time if we're not careful. Okay, so you zoom in over the 20% signal. It isn't particularly clear, but bear in mind you're seeing all of the signals across the full width of the scanner here. What we're really interested in is the one in the middle. Okay, so we'll just skip forward a little bit. Okay, this is how you go through the things. You pick up the center of the positive and negative peaks, and you kind of, I'm just going to skip through. So when you've done all that, you've picked your 20, 40, 60, 80% defects. You then head to the live screen. You can pick up, within that previous screen, you can pick different color palettes and things like that. So I'm now setting the threshold alarm to about 30% before we start doing an actual scan. You have to select a plate. You have to add a plate and configure it. In this version of software, it isn't actually necessary because you don't really need to store the data. But if you do want to store the data, at least you do have the option to add a plate here and record it. You'll see it flashing up idle and scanning. Okay, so when it's green, it means it's okay, it's moving forward. And this is actually the live display across 48 sensors here. And in the middle, you'll see my threshold bar, which is set at 30%. And what it's done is picked up some defects that are over 30% and listed them on the defect chart. And on the right-hand side, we're seeing the actual defects live on the kind of video strip display. Just going through. Actually, that's a good position to. So sorry, it doesn't make sense too much, but this is essentially now scanning through and looking at data that the machine has stored for one of the scans. And you can play with these back and forward arrow keys. You can essentially look at different parts of that sort of track of stored data. You can assess it, and you can decide to print a mini report to give to somebody to go and mark out the actual defect and prove it up. So here's some more stuff of the stored tracks. Okay, so this is another scan. We have a lot more defects spotted. It tends to say stop a lot because it was on these plates, the defects are very, very close together. So obviously the stop comes on, it doesn't just flash on off, it stays on for a second or two to give the operator a chance to identify these. If he wants to stop there, and he can. Okay. Well, I'll just skip back just a second here, if I can find where it's showing one of the defects. Bear with me. Okay. Okay, this is just one of those stored 30% plus defects that it picked up and stored for us. So it tells us it was this defect started at 1143 and ended at 1247 millimeters, and there's actually two on here, just caught in one picture of data. And it was a 36 to 53% wall loss. This is the 53 at this end, actually. This is the 36 here. And those are the sort of things we can store with the simple version of the alarm on defect software. I just want to go back a stage here and see if I can actually pick out the point where it. Oh, there we go. Okay, I'll just pause there. So what you can do at any point when you've got a stored tracker data here is essentially interrogate any one of these parts of the track, and it gives you the full picture. So this is the actual Hall effects response cross lift of the scanner at encoder point 1371 millimeters from where you started, and it's telling you it's actually a 98 reading. That's not percentage, actually, that's the non-corrected result, but it's a 78% wall loss is what it's picking up. So that's our 80% defect. So bear with me, I'll just press on a little bit because we are going to run out of time. I'll skip forward. So we've seen this. Okay, let me just go back a few seconds. Bear with me. So this is calibrating the mapping software at this point now. So I've moved on to the mapping software, doing the calibration of the mapping software. And essentially, when it's gone green, we're going over the test plate with the 20, 40, 60, and 80% defects showing. So it's a different software and it's a different interface for mapping as it is as compared to alarm on defect. We will eventually bring the two softwares together, but again, it's kind of work in progress to be honest at the moment. So this is the mapping software. This is how easy it is to calibrate the mapping software. You've got your 20, 40, and 80% defects. You put the cursors over them. You click exit, and then you're ready to go on and do some inspections. As you'll see here, we have the interface screen shown where you have a project, a tank, and a plate. You start by running through the project. You put the details of that project in. And this I'll just pause here a second. This is a this is a test tank that we sort of set up just for demonstration purposes. So each one of these plates is a stored plate of data. And what we don't do, and this is one of the things we will change in the next video, we don't actually show the individual defects in this whole tank view. What we do is this sort of histogram where these color bars actually represent the amount of each level of corrosion that is evident in that particular plate. So and this is plate 1.1 here, and you can see instantly it's got some defects in it. No matter how small they are, you have a bar going across that shows you that there's a defect in that plate. Let me just carry on playing this video. So we've now pushed on to adding a plate. So we're in the tank, we're deciding we want to do an extra plate, so we're going to row 5 and do plate 5.1. We press enter, and it goes into this screen where you then configure your plate. Okay, so this is the plate tab, and then you can adjust all the things. You've got the size of the plates you set in here. You decide whether you're going to do the end zones, which means you scan perpendicular to the track of the other scans. Bear with me a second, so I'll pause this here. So this is what we're trying to generate with the previous part of the video. So this is the size of the plate. So we're 8.15 wide in this case by 1.1 meters long, and the Truflux has automatically calculated the tracks, the scans we need to do within that to scan that whole plate. So we've got track 1, track 2, track 3, which will literally drive the scanner up and down those areas. Track 4 and track 5 are the end zones. So I can just speed this up a little bit because we're going to run out of time. So if I just scroll through, you see the defects popping up. So these are all the various tracks as we've done them, track 4, track 5. Then when you've done that, you end up with this large screen here with all the defects shown for the whole plate. You can zoom in, look at an individual defect, and you can show, it tells us here that this defect is actually a 390-400 millimeters across the plate, and it's sort of 560 along, 570 along the plate. So you can instantly go in, find it, prove it up with ultrasonics. So I'm going to have to skip through the rest of this quite quickly. So bear with me while I just skip forward a little bit. You don't need to see all of this. So there's the plate now that we just scanned in the whole tank. I'm just going to move forward by 30 seconds. I just was doing a plate. So this is a plate here where we show that we can pause a scan partway through. So if you have an obstacle in a plate, you scan the first part of the plate here. You come up to the obstacle, you put the size of the obstacle, so I think it's 300 millimeters in this case, no, whatever it was, a few minutes, you dial it in here, then you continue to the end of the plate, and it shows you this, the area you couldn't scan is in your tank map. So, go forward. Okay, so these are the rest of the scans in that plate. Okay, and then we can create a report. So I'll click the create report button. You then, it sends it into the test file, which is the tank that we were doing. It's the last file in there. It's generated as a PDF report. And this is it here. So it's a tank survey. Excuse that, it's our friend Rodney who we were demonstrating to at the time. And let me just go back, sorry. And I'll just okay. So in the tank report here, you get the whole size of the tank. It tells you where all the plates are, so 1.1 up to 5.2, all laid out on the first page of your tank report. And then you can go through every sheet of the PDF report is one of the plates. And you can see quite quickly here, this is plate 2.3. These are the tracks of data that were required to scan that plate. And these are the actual results of that plate. So this is a very simple PDF report with everything you need printed out on it, or emailable, whatever you want to do with it. This is my last, so plate 4.3, goes through my last plate somewhere. This one, this is my last plate I did, plate 5.2, with the paused area where there's an obstacle in the way. And it's all there. So that's essentially the mapping software shown. Sorry again. Okay, how do I get back to? Sorry about this, I just lost control here somewhere. Okay, good. Bear with me a second, I'm just wondering why I can't go back to my PowerPoint yet. Okay, I'm not sure why I can't get back to my, this is my PC finger trouble here, guys, sorry. Okay, there we go, sorry about that. So that was the video of sorry to drag on a bit, the alarm on defects and the full mapping. I've just got a quick video here of an actual tank being scanned. This is some guys we've worked with in Israel, actually. So excuse the lack of headgear PPE, but this was just testing a fairly new scanner out, just making sure the guys knew how to use it. So it was a bit of training, as well as this is the tank they're about to go and scan straight after we finished. So you can see the scanner running along here. That's the sort of speed we run at. Fairly standard stuff if you've done any tank floor scanning before. These are the tracks that we gathered, tracks of data. Here we go, coming back. It's just turning the lights off for some reason, but there we go. You get a gist of what it does. So these plates here, you will scan every one of these plates. Normally you would mark them out with chalk lines, so you make sure you cover the whole plate properly. Okay. I'm going to just go back to the PowerPoint just so we can get through the rest of it. Excuse me. So that was some scanning. And this is actually a response from those same guys in Israel. They were the first people also to try the alarm on defect. I don't know if you can see here, but it says, these are pictures they sent me on WhatsApp. And they said proof it's a reliable and accurate pinpointing the location. So they found it very easy to use. They said they didn't have to go hunting around with their UT set to find the defects. Where the Truflux told them the defects were is exactly where they were. And in this case, you can see they actually found a through hole. They put the screwdriver in there to show us. So we know the machine works. We know it works well. And these guys went on and used this new software with absolutely no training required. These are some of the people we've sold the units to more recently. We've had success. You can see we've sold Singapore originally, then Indonesia, Fiji, Philippines, Taiwan, Brunei, and others. And we've got some quite good approvals here. People are have used the scanner and are using it in the field. This is the picture here of it boxed up, disassembled and boxed into one box. These days we actually ship it in 2 boxes if you would prefer. Okay. We had recent Truflux sales. We've had quite good success in the last year. We've gone to Mexico, Israel, Korea, India, Switzerland. It's getting a lot of sort of global coverage. And as a result of the success, actually, we're now building the machines in bigger volumes. We're building them 5 at a time, which has brought our costs down. So we've actually lowered the price, which Quinton and the guys at Intech, if anybody's interested, can tell you about. This is what you get in the box. You get the scanner, the laptop, which is semi-rugged or fully rugged, depending on what you choose. Spare batteries for the charger, spare batteries for the unit itself, for the charger for the PC. Spare batteries and a charger for the unit itself. Then you get the flight cases, so you can basically large Pelly cases, and we can provide the calibration plates if you don't have those yourselves. So that's pretty much it. Sorry, the last bit's been a bit of a whistle-stop tour of the machine. I was worried about running out of time, so I know we were aiming to finish 10 minutes before the hour so that we could have any questions. So that's me done. I don't know if you want to hand back to questions, Quinton.
Thanks, Pete. That's a great presentation. Thanks for putting that all together for us. So yeah, we've had a lot of questions come in. Gath has been able to answer pretty much all of them.
Okay.
I just wanted to maybe, depending on who'd seen which of the questions, just highlight to people, the ease of training for the system. There was a question about how long it takes. And Gath indicated 2 days maximum. Another thing from the poll is it seemed that a lot of people are very interested in discriminating between internal and external corrosion. But I think the big takeaway from this product is, let's look at price versus that sort of functionality, because there's always ways to prove that up at a later date after the fact, once you found the defects. So I guess it's for each company to look at and do a cost analysis and decide, what are you paying for and what are you getting. So that's a discussion we would love to have with some of our customers down the road here.
Yeah, absolutely. I haven't put competitors pricing in. We all kind of know what each other charges, I think, but we are definitely very, very competitive on pricing of this machine. And you get customers say we have to have top and bottom side differentiation, and other guys say, well, we can see it. You know, we've built it up, we can see it. We have to go back and prove it with UT anyway. And it's at the moment, it's horses for courses. You know, we have a scanner which does quite a lot. We admit it's short on top side, bottom side differentiation, and eventually, I guess one day that's something we will build into it. But it is a scanner. It does a really good job, and I think our real selling point is, besides the price, is the fact you can fix these things in the field. You know, you don't have to send it back to the UK or to the manufacturer or wherever it may be in the world to get it fixed, like you do with some of the other scanners.
I can just interject there, Pete.
Yep.
I was talking to one of our distributors in Taiwan today, and they over there have in excess of 4 units being used in the country, and we asked him how they were going, and he said, "Oh, there's only been one problem in the last few months," and he said the customer had a problem with their encoder, and they just replaced it themselves. They didn't even ask for anybody to do it; they just did it.
Yeah,
and this highlights just how simple to maintain the Truflux unit is.
Yeah, and I think that goes to one of the other questions that was asked of us. You know, will Intech NDE be able to do service and calibration? Of course, we will be able to. We have a service department here, but one of the highlights was the ease of repair that you guys have built into the system. So you know, if you're out in the field, you're able to do some repairs, if not all. But other than that, of course, you know, we're here as support, and you know, we'll lean on you guys too for assistance.
And actually, we're focusing on repairs a lot, but actually, they don't break that often. One of the comments previous on it's the most reliable scanner in the world. I think whether you believe that or not, I don't. You know, it's up to you to take on. But we believe it is very reliable. Actually, we don't get many failures. We had one of our customers actually driving the scanner over the welds, which obviously, I say obvious. Hopefully, it's obvious to most. So you don't want to drive this thing over the welds because the magnets are only 3 millimeters off the floor. But the customer's driving it over the welds. And the scanner, when it came back, was absolutely bashed. I don't want to say bashed to pieces because it was all still in one piece and it was still working. They managed to snap some belts by abusing the scanner, but actually replaced the belts, which they did themselves. And in fact, it never came back here for repair at all. It was all done in country by the guys themselves. I was thinking it came back, but it didn't. It never came back here. It never needed to. They showed us pictures of it. We thought, wow, that's had some abuse in its life. And actually, maybe coming back to again, the guy. This was several years ago, and they may be sending it in for a full refurb, but it's still working. You know, it's a good unit. It's so you don't need to do lots of repairs. Let's not focus on it too much. But if you do need to do them, you can do them yourselves.
Yeah. Absolutely. I'm just going through some of the answered questions to see if there's anything else that we should cover.
Peter, there was a question about what's the minimum defect size this unit will detect. I know it detects down to 20%, but I also know you've been looking at lower defect levels for other customers.
Yeah, I mean, our view generally is 20% wall loss is about as small as you're going to ever really want to go reliably, because generally noise and you can get lower on a test plate in the lab here. You can do better than 20% wall loss, but the reality is when you get out in the field, there's so many other things affecting the scan that it's not practical to go below 20. And in fact, if you look at the health and safety executive document, which I shared earlier, or I referenced earlier, it says that in there that they don't really recommend trying to find things not with our scanners, because our scanner was actually used in the trials, but less than 40%. And typically, a lot of people aren't interested in stuff less than, you know, more than if it's less than 60% wall loss, they're happy with it. And a lot of customers I've seen are only literally looking at 40% or greater wall loss. So we've got more questions coming in here.
One of them, Pete, is about license fees, and I was just going to say that there are no license fees for using this unit, whether it be annually or initially or whatever. And from the poll earlier on, I noticed that there were some people who were quite happy to pay for software upgrades.
Okay.
If you were our customers, we would probably have to upset you, because we wouldn't actually charge you for software upgrades.
No, we're typically, that's not a model we're going along, to be honest. We don't need to do it. We don't, you know, if we could do it, then great, but who want, you know, it's different business models, and our business model isn't to need to do that at the moment. So, and that's not something we ever plan to do, as far as I'm aware. I've got a question here. What's the typical testing time for a 60-foot diameter tank? To be honest, I don't know.
I think the question there is more relating to how does it compare to existing scanners? You know, is it faster, slower, or the same? I think that's the best way to answer that question.
To be honest, I would say the same. It's going to take, if you're using the mapping software, it's going to take you slightly longer because you're gathering data and you're doing things with that data. But it's pretty much the same. I mean, there are scanners that you can run some scanners faster. You can run ours faster if you can prove on a test base that it finds a defect. You can run the scanner at 1 meter a second, but we generally find 500 millimeters a second is adequate. And I'm not sure about a 60-foot diameter tank, but I can refer to the last scanner we sold, which actually went out here just before Christmas. The guy used it. He went out and used it straight away with no very minimal training, talked through by us on WebEx or Zoom calls or whatever. Took the manual, went off and used it, and he did a 90-meter diameter tank. I'm pretty sure he said he did it in 3 or 4 days, the whole tank. So that's a lot of scanning in 3 days, and a 90-meter diameter tank. That's a lot of plates to do in that time. So it didn't take long, and from our point of view as a unit we sold, we were anticipating lots of questions coming back because he'd never used one of our scanners before. He's a very experienced tank floors inspector, but he'd never used our scanner before. So when I saw an email from him, he's got a question on how to use the scanner, and he said, "Oh, I finished. I've done a 90-meter diameter tank. All went well. Thanks for supplying this, that, and the other." So it was a real surprise, and they got on and just did it with minimal help.
Okay, well, that's great. We are out of time here, but Pete and Gav, thank you so much for putting this together. If there's anybody on the line that wants any further questions answered, please feel free to get hold of us at Intech. We will do our best to get these answers back to you in a speedy manner. So yes, enjoy the rest of your morning, enjoy your evening, I guess, Pete and Gav, and we will talk to you soon. Thanks a lot.
No, thank you, everybody. Thank you for taking the time to listen to me waffling on. Hopefully it was interesting.
Thanks again.
Thank you, guys.